All right, so 4.1, scatter diagrams and correlation. Um, Especially this first section, there's a lot of writing just setting the foundation, making sure we understand what a scatter diagram is, correlation, and all the good stuff like that. So just give you a heads up as to how this section is set up. So scatter diagrams and correlation. A scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. All right, each individual in the data set is represented by a point. All right, we will have an explanatory variable and a response variable. We'll talk about the differences between the two shortly. Trying to give you guys a chance to write. All right. If I scroll too fast, of course, let me know. All right, so we're looking at the difference between the explanatory variable and the response variable. All right, your explanatory variable explains the value of the response variable, wherein the response variable is actually explained by the explanatory variable. Basically, the explanatory response variable responds to what the explanatory variable gives you. And so when we give an actual example, you'll see in a second what we mean by that. Your explanatory is your X, Y, your response is Y. That's your domain versus your range, input versus output, independent, while your response is dependent. Your explanatory will be your horizontal. Vertical axis will be your response. And what's really going to be big for us is the predictor versus the predicted. All right, so right here is just a general example of what your scatter plot will look like. If you remember your XY axis, we're just looking at the first quadrant. That's all we're using here is just the first quadrant. And so your horizontal axis will be your explanatory variable. Vertical axis will be your response variable. All right, while using our scatter plots, we will be looking for linear relations. And that's going to be when a line best sums up the shape of the scatter plot. Those are going to be the things that matter the most to us when we're talking about our analyzation in this section. We're in chapter 4, period. So we look at the first three. See right here, we have a linear relation. Even though every single dot doesn't land on a line, but a line best sums up the direction of the graph. Same thing here. And then you see this one there is a pattern, but it's not a linear pattern. Notice it's like an arch. Same thing here with this fourth one. There is a relation. It's just not a linear relation, so it's non-linear. And this one right here is not considered having a relation at all. And so that's why I wrote in the purple. Non-linear does not mean no relation, just no linear relation. All right. All right, associations. A relationship is positively associated. When one value increases, the other increases as well. So you see here that as we go from left to right, our dots are going up. It's negatively associated. When one value increases, the other one decreases. So see here, looking at our dots, as we follow them from left to right, they go down. So the difference between being positively associated versus negatively associated.
I wasn't able to get the writing in purple above the associations.
All right. There you go. Yep, no problem. No problem. All right. Any questions? All right. Try to give you a chance to finish that up. All right. So linear correlation coefficient is a measure of strength and direction of the linear relation between two quantitative variables. So remember before we talked about symbols used for your population versus symbol used for your sample. So there's Greek letter rho. I know it looks kind of like a P, but it's actually Greek letter rho. That's what I have right here. And that's your population correlation coefficient. And then your regular letter R, that's just a simple R. That's your sample correlation coefficient. So that's the one we will use. We're going to use R, and that's what I wrote right here as far as notation. We will be using R, but I was showing you rho just in case my math lab were to mention it. All right, everybody okay? All right, so similarly to when we had the standard deviation and the variance, I want you to do the same thing with the correlation coefficient and the regression line. Correlation coefficient is coming out of 4.1. We're going to talk more about it in a second. Yep, got the properties next. But at 4.2 is your regression line. And both of them you can find at easycalculation.com. You know, like I mentioned before, just Google correlation coefficient calculator or correlation coefficient easy calculation, or and then regression line, easy calculation, either way. I know easycalculation.com works. If not, just fine. If you don't want to use easycalculation.com, that's just fine. Use whatever you like as long as it is reliable. Make sure it's reliable, and you'll find it out very quickly. You know, when you start putting your answers in my math lab. All right, but you are not held responsible for the actual formula. All right, I'll scroll up. All right, so now we get into the properties of the correlation coefficient. It says it is between -1 and +1 inclusive. So that means it can be 1, it can be -1, but it cannot go smaller or larger than that. All right, so now if it's +1, then a perfect positive linear relation exists. If R is equal to -1, then a perfect negative linear relation exists. All right. Number 4, the closer R is to +1, the stronger the evidence of positive association. Number 5, the closer R is to -1, the stronger the evidence of a negative association. All right. If R is close to 0, then little or no evidence exists of a linear relation. And so R close to 0 does not imply no relation, just no linear relation. All right, 7, it is a unitless measure of association. And then 8, it is not resistant. So that means it is affected by outliers. Remember, we talked about being resistant versus not being resistant. I think it was last class, might be class 4 last, when outliers do affect it. So outliers will affect your correlation coefficient. All right, everybody good. All right, so here are just generic examples of what it means for R to be equal to positive 1. Notice we have a straight line here. So that's a perfect positive association. Then as we deviate from that positive 1 and start to move away from 1 and go closer to 0, same thing here. Notice we have 0.4 and the dots are more spread out. Same thing goes for negative 1. We have a positive, not a positive, we have a straight line. So that's a perfect negative association. And then as it deviates from that line, it gets wider and wider, or the dots spread out more from the line. This sixth one, R is close to 0. Once again, you see that there is a relation. It's just not linear. And also, this will be close to 0 as well. And there's no relation there. All right, any problems? Any problems? All right, so the next thing is to test for a linear relation. I believe I have that chart. Let me see. I don't think what I'm doing right now is blocking you guys' view. If it is, let me know. All right, well, I guess I'll just have to go into the table, into the book, ebook. All right, so testing for a linear relation. Your steps first before we go there. So determine the absolute value of the correlation coefficient. Find the critical value from Appendix A, Table 2, Appendix A, for the given sample size. I meant to write Table 2 in there, that's why I Try to squeeze in there in red. If the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two variables. Otherwise, no linear relation exists. I'm trying to pull up this e-text, but once again, if when I'm doing blocks, you guys notes, let me know. Trying to do that while you guys copy. All right, so it's not going. What's wrong? All right, so no stuff not coming up. Okay, give me 1 second. So anyway, let's go ahead and at least start the problem, and then I'll try to pull it up again. So determine whether a linear relation exists between the club head speed and distance. All right. So to give us this chart, so the club head speed is 100. So in other words, we're talking about a golfer swinging a club. He's swinging at 100 miles per hour. His first observation, swung it at 100 miles per hour, and the distance the ball travels 257 yards. All right. So this is the explanatory variable. This is the response variable. So in other words, how hard or how fast he swung the club determine how far the ball traveled. In other words, the ball responded, the distance the ball traveled responded to how hard or how fast he swung the golf club. So, that's the difference between explanatory and response variable. The response variable is responding to what happened, and as far as the explanatory variable is concerned, or in other words, the explanatory variable explains why the ball traveled, or why what happens in the response variable. So you copy those values down. Yeah, it's day 2. Try one more time. Let's try doing this. All right. So find the correlation coefficient. There's my phone so I can take a picture of these data values and plug them in. So I'll show you how I would do it. Oh, that's why I pulled up the wrong e-text. Gotcha. All right, so I would go correlation, coefficient, easy calculator. So correlation coefficient, easycalculation.com is what I would use. Like I said, you don't have to use it. But you see how this one's set up for you. X value is your explanatory. Y value is your response. So you can add rows or take them away. So got 100, 57. All right, so I typed in all the data values and always make sure that they are correct because one digit will change it all. So here we have 8 total observations. So, you know, that 100 goes with 275, the 102 goes with 264, and so on. And here's our correlation. And always make sure you pay attention to my math lab because they'll let you know how many decimals they want. Normally I write in notes, 4 decimal places out. My math lab will let you know if they want 3, 4, or whatever. And like I said, make sure you're careful with this. So let's say if I do 256 instead of 257, notice that it changed my correlation completely. So notice that's 9314. If I change it back to 7, 93869. So one digit will make all the difference in the world. So make sure you go back and check your data values. And you go about doing your input. So before we go any further, questions on how I expect you to calculate your correlation coefficient? Everybody good? Everybody straight? So like I said, find a website, Apple calculator to knock it out for you. Just make sure it's reliable. Use things like I just gave you an example that, as long as you get that same result, you should be good to go. All right. So that's why my pages couldn't come up. I'm in the wrong class. Thought for sure I put 254. 245. All right, so while that comes up, so we found that our correlation coefficient was 0.939. Like I said, according to my math lab, I believe the book, the example went 939. So I went 939 as well. But my math lab may ask for 4. So like I said, pay attention to that. Then you're going to take the absolute value of R. When you talk about absolute value, that's what I did right here. Just make sure we're clear on that. Taking the absolute value number always yields a positive result. So if you take the absolute value of 3, the result is 3. If you take the absolute value of -3, the result is still 3. So when they say take the absolute value of R, remember R can be positive, but R could also be negative. What they're trying to ensure is that you have the positive result. We had 0.939 as R. Absolute value of 0.939 is still 0.939. So like I said, what they're trying to do though is make sure that you always have the positive result. So if you had a negative 0.939, they want you to still use the positive 0.939. So question of absolute value always yields the positive result. All right, so let me see if my chart came up yet. Hold on. All right, so we see in the chart, it says, number 3, it says find a critical value from table 2 in appendix. And that appendix is page A2. So let's go. Hold on. So was I sharing my notes? Did you guys see this when I was talking about it, or y'all let me just talk? So I was talking, but just to make sure, I don't know if you guys had the notes up when I was talking about absolute value. So this is what I was talking about right here. Um, Absolute value of positive 3 is 3. Absolute value of negative 3 is also 3. And so we took the absolute value of 0.939, and that's what we got, which is positive 0.939. Absolute value always yields the positive result. All right, so now if we go to the e-text, type in A-2. That should work for us this time. Yep, there we go. So this is the table. All right. So the value that we're going to pull from this table is based on the number of observations that we have. If you go count back, we had 8 observations, so that's our N. So you count here, he swung the club 8 different times. 1, 2, 3, 4, 5, 6, 7, 8. So he swung the club 8 different times. Almost, where's my slashes? All right, so that's why N is 8. And then if you look at the chart, see, let me write now, I won't. But if you look at the chart right here at 8, your critical value is 0.707. All right. Problems with reading the chart? Everybody okay? All right. So we have 0.707 from the chart. Now we're going to compare. Step 4, compare the absolute value of the correlation coefficient and the critical value. And the conclusion right here is that R is greater than that critical value. 0.939 is greater than 0.707. All right. And since the absolute value of R is greater than the critical value, then a linear relation exists between the club head speed and the distance. So once again, if R wasn't greater than the critical value, then there would not be a linear relation between the two. All right, questions.
Can you scroll back up to number 3?
Sure can.
Thank you.
Not a problem. You guys let me know when you're ready to move on. think that is, yep, that's it for 4-1. So, questions on anything I've said before we look at 4-2? All right, are we good? Anybody still copying? All right, so let's look at, let me go back. All right, so let me check one thing before I go into 4-2. Nah, I won't worry about that. All right, let's go ahead and knock out 4-2. All right, so 4.2 least squares regression is the line that minimizes the sum of the squared errors or residuals. It's the line that best explains the relationship of the data. All right, and that red line just an example of what we mean by least squares regression line, the line that best summarizes the data or best explains the relationship. We will also use it to predict outcomes based on observations we've already seen. So like if we were talking about the golf club and the guy swinging the golf club, based on the observations that we have, we'll be able to predict if you were to swing it at a certain speed, how far would the ball travel based on previous observations. All right. So we want to define the regression line. It is given by this formula right here. Y hat is equal to B1x plus B naught or B0 So this symbol right here is going to be hat. So, no, that was my other class. So if you ever have that over a variable, then is that variable hat, so that will be y hat. And that represents our predicted y, the value we're going to predict. All right. So the way we'll find B1 is by taking R times S sub Y over S sub X. And when my math lab asks for the slope, that would be your slope. B1 is your slope. B0 is Y bar minus B1 times X bar. And that's called your y-intercept. Okay, that's it. So R is your correlation coefficient, like we mentioned last section. X bar is the mean of your X values. S sub X is the standard deviation of your X values. Y bar is the mean of your Y values. S sub Y is the standard deviation of your Y values. All right, are we good? And the purpose of what I was mentioning before about a regression line, the regression line is used to predict an outcome based on previous observations. All right. So there are two ways that we can get our information in order to be able to calculate the regression line. The first way we're looking at is if they give us R, X bar, S sub X, Y bar, and S sub Y. So they may give you these 5 data values, and then all you would do is plug them into the formula according to what we have set up here. All right. So looking at this first one, they give us R, our correlation coefficient, to be negative 0.946, X bar 4, S sub X 2.44949, Y bar is 10, and S sub Y 5.612486. All right. So follow the formula. Finding B1 is R times S sub Y over S sub X. That's what we did right here. That gave us B1 as negative 2.1676. So keep in mind, you have to find B1 first because you go back to the formula. Notice B1 is a part of the formula to find B0, B sub 0. So after you find B1, you find B0, Y bar minus B1 times X bar. All right. And then the third step is to go ahead and plug them in. So you notice after we found B1, we found B0, 10 minus negative 2.1676 times 4. That gave us 18.67404. Make sure you don't lose a negative right there because, of course, that matters. And plug them into the formula. So here I was just saying be careful. That's how my math lab a lot of times will give you the ability to plug in the values. And so they'll give it a box, one sitting in front of X, then the other one is, alone. So make sure you're putting these numbers properly. This one goes in front of X, then this one goes in the box that's alone, or they could have it wherein the X term is in the back, so just be careful which way they have it. The value that's in front of X will always be in front of X, so just be careful with that. All right, any problem with that one before we look at the next example? All right, so let you write those directions down first. So for the next example, we're going to find a regression line. Then we're going to predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. And then for C, determine the residual for the predicted value from the result in C. And then is the distance in the table above or below average among balls hit at 103 miles per hour? All right, so let's do it. So we're going to use, let me erase this right here. Use the same data value from the club head speed and the distance. And just to show you, we'll come back to that. So once again, regression line. Go on some easy calculation. And so regression line, easy calculation. And then same type of deal, type in your data values and you will get your, your regression line. It'll separate, give you slope, then y-intercept, and then give you the line itself. So just showing you, like I said, the same type of deal. Just type in that and easy calculation behind it, and it will give you your options. First one is regression is on easycalculation.com. but there are other options down here as well. And once again, you know, if you want to use an app, you know, there are a bunch of free things out there that you can use. Going back to the notes, when you type in those data values, you will get this as your regression line. So this is the other way you could get your data. So notice last time they gave us pieces. They gave us 5 pieces to plug into the formula, plug those into the formula, and we got out our regression line. So we had to calculate it. Here they gave us the data values. Here they gave us the data values, gave us the chart. So we went to a website, typed those in, and we will get our regression line. All right, and notice here, regardless as to which way you write it, notice the 55.797 is negative, 3.166 is positive. All right, so any questions on A before we go to B? Make sure we're okay. All right, so B is predict the distance the ball will travel when hit with a club head speed of 103 miles per hour. So that means you're going to take X and let that be 103, and you plug it into your regression line. So plug that 103 into the equation. 3.166 times 103 minus 55.797 will give you 270.3 yards. All right. Any problems with B? Okay, looking at C, determine the residual for the predicted value from the result in C. Is the distance in the table above or below average among balls hit at 103 miles per hour? So we notice that we do have an observation at 103 miles per hour, which is when he swung the ball, swung the club at 103 miles per hour, the ball went 274 yards. So your residual, the way you calculate your residual or your error, talked about that in the earlier part of 4.1, you'll take your observed y minus your predicted y. So symbolically, that's y minus y hat, right here. And y is 274, that's our chart value, minus our equation or calculated value, which is 270.3. And that's 3.7 yards. All right. So conclusion, the observation in the chart is above average. Balls hit at 103 miles per hour. And it is above. And why didn't I go all the way to the above? So anyway, that arrow should go all the way to here. So it is above because it is positive. Now, if that was negative 3.7, then it would have been below average balls hit at 103 miles per hour. right, questions? Any questions? Is everybody okay? All right. So 4.3 is short. So we'll knock that out and then we'll talk about how we're going to move as far as next class is concerned. I'll make sure everybody's written everything you need. Everybody okay? All right. So 4.3, the coefficient of determination. It measures the proportion of total variation in the response variable that is explained by the regression line. So it basically tells how reliable the regression line is, and it's the correlation coefficient squared. All right. It's denoted by capital R squared. It is between 0 and 1 inclusive. If R squared is equal to 0, the correlation coefficient of determination is equal to 0, the regression line has no explanatory variable. Value, excuse me, no explanatory value. In other words, the regression line has no meaning. All right. If the coefficient of determination is equal to 1, the regression line explains 100% of the variation in the response variable. So it will always be right. All right. So determine and interpret the coefficient of determination for the club head speed versus the distance. All right, are we good with the black?
No, I'm sorry. My pens keep going out. I'm not exactly sure why. Do you mind?
It's all good.
This is my fourth pen that I've had to go get. I'm not, I don't know. You
It's
mind
all good.
scrolling up a little bit more?
Yeah, let me know when to stop.
Yeah, that's good. Thank you.
Okay. Uh-huh.
All right, I just took a screenshot of it. Thank you.
Oh, okay. All right. Not a problem. All right. So we want to determine and interpret the coefficient of determination for the club head speed versus the distance. So first step, we want to find the correlation coefficient. We've already done that. R was equal to 0.939. So then find the coefficient of determination. That means you're going to square R. And that's 0.882, or it could be interpreted as 88.2%. Give you a chance to write that. All right, so now we can interpret it. That's all there is to that. If you already have your correlation coefficient, then all you do is square it, and that's the coefficient of determination. So the interpretation of that, and yeah, don't let me scroll up too far if you guys are still using the red. 88.2% of the variation in distance is explained by the regression line. That means 11.8%, in other words, subtracted from a 100. 11.8% of the variation is explained by other factors. So in other words, you're talking about hitting a golf ball outside, anything could come into play, wind could blow, the friction in the air. You might have twisted your hip one way that you didn't do, all the other way. Anything could be a reason as to why the regression line isn't as accurate as it would be 88% of the time. And so that just means that the regression line has an 88.2% reliability. So 88.2% of the time, the regression line should be correct in its prediction. All right, questions, any questions? Make sure we're okay. All right, everybody good? Everybody straight? Anybody still copying? Can I move off the page? I see a thumbs up. Okay. Let me see here. So just to give you a heads up, and this is what we're gonna do. Next class, I will not cover any new material. That's it for chapter 4. Chapter 4 is just 4.1 through 4.3. And since they connected and, we have all this time, I didn't want to, it just felt better to just flow with it as far as the notes were concerned. So next class, I will answer whatever questions you guys may have. So remember, everything that what you guys are responsible for up to this point is chapter 1, 2, 3, and 4 as far as my math lab homework is concerned. I know somebody had emailed me before about the assignments. Don't worry about those assignments. I want you guys to get your homework done because that's really the bulk of your grade as far as just regular assignments are concerned. Then you have test 1. Let me do it like this. Chapter 1, 2 is test 1. Then chapter 3, 4 is test 2. And then also we did definitions. Let's go chapter 1, that was definitions 1. And then chapter 2 was definitions 2. Yep, so you guys have enough work. Like I said, I don't have to pile it up. So we're not going to go into chapter 5 next class, but I will leave the floor open for any questions you guys want to ask coming into, for next class. I mean, if you don't have any questions, then, it's all good. You're just good to go, So all I will be doing is answering questions on next class. No new material. All right. Questions? Any questions? And all this stuff is posted in my math lab. If you have any questions about where to find it, as a matter of fact, let me make sure. I think I still have my math lab up. Yeah. So you see it right here. Chapter 1 and 2 definitions. And homework is right here. It's your homework tab. If it'll pop up. Internet slow, I guess. And then your quizzes and tests tab is right here. There we go. Oh, I posted test 3. Oh, that's another class. Yep. So that's where your quiz and test will be, and then your homework is right here. Well, whenever it pop up. Anyway, you saw it pop up. All right. So questions on that? Anything? Anybody? Favorite homework. All right. Also, don't forget these test reviews are not mandatory, but you can get extra credit if you are doing get 85 or better, and go from there. Anything? Anybody before we dismiss tonight? All right, good. Everybody straight.
So all the lectures are posted online, right?
Mm-hmm.
Okay.
Yep. I think I sent you guys link this morning. I think that's when I sent you guys link. So as always, I always shoot it out to you guys in the email, and then I archive it in Canvas announcements. So let's see if it still let me. Log me out. But if you go into Canvas and go into announcements, you'll see it will be titled class lecture links.
Okay. All right.
Yep. And if ever anybody have problems seeing those or finding them, just let me know, and we know we can walk through that. All right. Anything else? Anybody else? All right. So you guys have a good one. Be safe, and I will see you on next class.
Yep. Have a good one.
All right. Thanks. Do the same.
Thank you.
Thank you. Have a good one.
Thank you.
Thank you. Take care. All right.